we are going to talk a bit about a 1.0 release and what that means and what's coming afterwards. But yeah, given we are planning to release a 1.0, we want to also look a little bit back and at the history. So GeoPandas actually turns 11 a bit later in summer, because GeoPandas started at the SciPy conference of 2013. I was not there myself, so I can only tell from what I heard. But so it was started by Kelsey Jordal, who is seen here, giving a talk at SciPy of 2014. So the year later, when there was a 0.1 release of GeoPandas, where he, in the talk, presents GeoPandas and tells that the year before, he gave a tutorial on working with spatial data. And from that tutorial, from giving that tutorial, from getting some questions like, yeah, how can we make this easier? He started hacking during the conference, and by the end of the conference at the sprint, there was like essentially GeoPandas was born. At the time, tools like Shapely, Fiona already existed, Pandas already existed, so it was like a matter of like how can we connect all those tools that already exist? How can we make that easier to work with tabular vector data, geometry data? And essentially, yeah, what he presented at the time, like explaining what GeoPandas is or what the goal is yeah, very much still the same as what it is today. It's connecting yeah, those different libraries, make them work together to make it easier to work with this kind of data. So 0.1 release in 2014. I joined a bit later after the 0.1 release, and I took over the maintainership from Kelsey in 2016. In the meantime, I'm also not the only lead maintainer. Martin is there as well. Some other people as well. A funny note in the timeline of GeoPandas is that at some point, we were actually thinking to do a 1.0 release because I created a tag in 2017, which was called 1.0 dev. The main reason to have that tag is because we had a branch, an experimental branch, that we were thinking that might become the 1.0 release of GeoPandas, and I wanted that people could try it out. So there was even a Conda Forge like development release at the time. But so that was this experimental Cython branch, and that was to improve the performance of GeoPandas. Now, it didn't, things turned out a bit different than what we initially thought in 2017, because yeah, here we are, 7 years later. But what we started back then is still many of the improvements that came along the years. So some things in our dependencies have been changed, improved to enable essentially the work that we wanted to do then, which is improve the performance of GeoPandas. So one thing was integration with pandas to have make it easier to create like your own custom data type, which helped a lot to make it possible. I'm going to skip those for a moment, and then essentially the work, like, yeah, the Cython branch became PyGEOS, or we collaborated with the PyGEOS developer. PyGEOS then later also became Shapely 2, and that's for, yeah, I will mention that a bit later as well, but that's a big reason, a big yeah, step now for calling GeoPandas 1.0, like the improvements in Shapely. There also have been other improvements like yeah, better integration with pyproj, better faster I/O with pyogrio, some other new methods. In the meantime, we also became a new focus affiliated project, and since recently also a sponsored project, which means that we can actually accept donations. GeoPandas is still almost entirely volunteer run project, but so now, yeah, we can accept donations. Then let's go to actual 1.0 release. What's changed? What does it mean? Maybe a question that people will ask, like, is it stable now that we have a 1.0? I think in general, we can say that GeoPandas has been quite stable for several years. It's widely used, people relying on it. So the 1.0 release doesn't really change much there. We did make use of the occasion to have a few breaking changes, but they are, I think, very limited. One example is that the spatial join will now preserve the name of the index. If you are joining two data frames that had an index with a name, it will now preserve that name. And it's a breaking change because your resulting data frame actually has a column, like before it was always called, the column name was always index right, index underscore right. And now that name will change. So if you relied on the fact that it was called index right, then that can be a breaking change. So there are a few of those smaller corner cases, but only very few. Another big, some larger changes are related to our dependencies. And focusing, showing the dependency structure of GeoPandas, the main dependencies. We have more dependencies, but the main dependencies, you have pandas for the tabular data structure, and then the core spatial geospatial dependencies, Shapely, Fiona, pyproj, which are wrappers of the underlying GEOS, GDAL, and PROJ libraries. One thing that we did was essentially making everything that can be optional, optional. So you can run GeoPandas with just pandas and Shapely without having to install GDAL if you don't need the I/O, or without having needing PROJ if you don't require reprotections. We actually still install those by default. So if you do pip install GeoPandas, you will still get all those dependencies, but you can install GeoPandas without it, or it can run without it. So that's the slimmed down dependencies. For Conda Forge, there is actually, you can Conda install GeoPandas base, and at that point you only get those strictly required dependencies. Another big change is Shapely 2 is now required. Until now, we had support for both older versions of Shapely, the PyGEOS package that was integrated into Shapely. But yeah, to ensure everyone uses the latest Shapely, has the benefit of the performance improvements of that, and also because we could clean up a lot of code in GeoPandas thanks to Shapely 2. That's now a requirement. And then an important one, I will later show some of the performance impacts of this, but we have always included Fiona as a dependency for I/O using GDAL, but the 1.0 release will switch to include pyogrio by default. You can still use Fiona, but it's the default that comes with installing GeoPandas will be pyogrio. And so if you relied on the fact that Fiona was present in your environment just from installing GeoPandas, that's also something that's, that will change. That's something, about the dependencies. Let's look at some new features.
Yeah, you have not only changed stuff, we have also added a lot of new stuff. And primarily, it was done through the Shapely Parity project, which was luckily funded by NumFocus, so we thank NumFocus for that. We put a lot of effort over the last, I think, year and a half, ensuring that the functionality of Shapely is fully exposed on the level of GeoPandas GeoData frame and GeoSeries. So we now have, on top of the stuff which was there until, let's say, 0.12, quite a few new methods allowing you to do different things, but most importantly, allowing you to stay within the GeoPandas and its API without needing to go to Shapely very, very often. And there are some minor changes related to this, and slight deviations from how Shapely treats things. This is essentially a deprecation right now. We had for years, I think even from 0.1 even, property unary union, which is now deprecated and is changing into union all method, which has right now 2 different algorithms are used inside there depending on your data set, where the unary one is the standard you well know, and the coverage union is optimized for polygonal coverages. And in future there are also other ways coming, like disjoint union for stuff which is kind of subdivided into clusters, and maybe some other unions depending on developments in GEOS. The same is exposed within the dissolve method, so you can make use of this as well. You will see by comparing the 2 methods that the performance boosts are something bit like 10 times faster using the coverage union. It very much depends on the data and somehow also on the machine you're running it on. We have included new predicates within spatial join and within spatial index query called dwithin, which stands for distance within. So if we are interested in joining data frames based on distance, you don't have to do a buffer and then intersects any longer. You can use dwithin with additional distance argument, and it's gonna use spatial index, and it's gonna be much faster than building the buffer yourself and doing the intersections, and more memory efficient. Yeah, the same if you want to use the lower level API, it's exposed in the S-index query. We're also trying to keep up with the developments within the GeoParquet and GeoArrow lens. So GeoPandas 1.0 will support the new, or actually upcoming specification of GeoParquet 1.1, which allows 2 different things. One is to include covering bounding box column within the parquet structure, and therefore allows us to efficiently read a spatial subset of data without reading everything and then filtering. And it also allows us to change the encoding of geometries within the GeoParquet file from well-known binary, which is what the current specification is using, into the native GeoArrow specification, which tends to be faster than WKB. GeoPandas datasets module no longer exists. We had it for a long time. It was used across our documentation, and it was used across a lot of teaching materials from the whole community, but we decided to remove those and replace them essentially with a new package that lives on its own. It's called GeoDatasets. And for example, if you want to get the New York boroughs datasets, which was originally included in GeoPandas datasets, the API is not changing a lot. You just import get path from GeoDatasets instead of GeoPandas.datasets. The difference is that the datasets themselves are not shipped as part of the package, but are pulled from the internet on demand. And the main difference is that there are no contested political boundaries included in the list of datasets, which was not the case in the original GeoPandas datasets, because there were natural earth low resolution datasets representing the boundaries of different countries, which led to some issues and a lot of anger over the internet. Once we kind of realized that the Ukraine in the datasets in the natural earth actually doesn't include Crimea, that's linked to Russia in there, we made a quick fix of the dataset and decided to remove them and keep GeoPandas away from politics, away from data, focusing on the software and the spatial algorithms we all like, and kind of shield ourselves from all this. Another application mostly trying to keep up with the API known from Shapely. The spatial index query bulk method is now query method, so this is enforced deprecation right now. And the similar situation is with the specification of predicate within spatial joins. Originally it was OP, right now it's more explicit predicate, and you will have to use it right now because I think the deprecation notice was there since 0.12, if I remember correctly. This is more kind of very lower level warning in here. For those of you who were using PyGEOS directly and you were relying on the fact that if you extracted the data from the geometry array, it was NumPy array of PyGEOS geometries, that no longer works. First of all, those are no PyGEOS geometries any longer. We have Shapely geometries under the hood, but to avoid the access in a way which is not necessarily meant to be like this, we have deprecated the .data property, and you have to explicitly convert the geometry array to NumPy. And Joris will tell you if it's actually any faster than it was before.
Yeah, I already mentioned that with some of the improvements in our dependencies, we have some speed improvements. But again, it's mostly because of dependencies, and it's not necessarily new for 1.0 GeoPandas. Shapely 2.0 was already was released a bit more than a year ago. So you could already use GeoPandas with Shapely, or even before you might have been using GeoPandas with PyGEOS, and then this is nothing new. The main thing is that right now with GeoPandas 1, we say we require everyone to use Shapely 2. And here are a few older plots. I released a plot from my talk of last year on GeoPython about Shapely 2, is that, yeah, for the core operations, we can you can expect quite some improvement depending on how cheap the operation is. For something very fast like contains, you can see like in this case 80 times improvement. For operations that are a bit more expensive, the speed up will be a bit different. Of course, this is for individual operations that were tested here. In practice, you have a whole pipeline with different operations and not only Shapely operations. So it will, of course, depend in practice how much improvement you see. One other example is for the spatial join. Also there, thanks to improved interface of the spatial index under the hood, also the spatial join has seen a very nice speed improvement. That's for all the core geospatial operations, so for all the methods that use Shapely under the hood. For I/O, I already mentioned that we switched from Fiona to pyogrio as a default library that is installed that provides you access to every file format that GDAL supports. Again, here, that will give a very nice performance speed up. So in this case, there's an example of reading a polygon data set of New Zealand building outlines. It's a GeoPackage file, a bit more than a gigabyte. And you can see how reading it with pyogrio instead of Fiona gives a very good speed up. The main reason for this is that Fiona is a very a nice library, but a general purpose library for iterating through features of the data sets. While for the use case of GeoPandas, we don't necessarily want to iterate through features. We just want to get those features in bulk because we want to build up the whole data frame, and we don't necessarily need a Python interface to iterate through those. And essentially, that's what pyogrio does. It just does the iteration at the level of Python in C, builds up the whole array, and then passes that to pandas. There's actually even further improvement here in pyogrio, thanks to new developments in GDAL using arrow to transfer the data, but that's and it can lower the bar of 25 seconds even further to 5 to 10 seconds, but that's something that I have a talk about tomorrow. So it's a lot faster. At the same time, it's also a bit more memory efficient. So on the right, you see the memory usage of reading that file.
Let me spend the final slides of the talk talking about what's coming after 1.0. 1.0 is strictly speaking not released yet, but we can still look a bit beyond that. Obviously, we want to keep up with GEOS and Shapely. So right now we have parity. We want to make sure that this remains the same. We're also going to spend some time exposing stuff from GEOS into Shapely so we can then consume it within GeoPandas. And one of the big things that's coming in Shapely 2.1 and hence GeoPandas 1.1, hopefully, is coverage simplification. Because right now, if you have a geodata frame representing a coverage, like the states of Africa, if you call simplify, every geometry is going to be simplified on its own, resulting in gaps and topological issues within the contiguity between geometries. While coverage simplification can treat the whole geometry array as one coverage and simplify it while keeping the topological relationships untouched. We are also hoping to expose coverage validation because right now if you are using the coverage methods, you kind of need to know or assume that your data are proper coverage. It may very often look like it is proper coverage, but it may not necessarily be. So we hope to be able to validate that. And in upcoming GEOS 3.13, there's a support for curved geometry types like circular strings, curved polygons. This is most likely eventually make its way into Shapely and GeoPandas, but the timeline for that is unknown yet because we are hoping to include this as soon as it's supported in most of the geometric operations, which I don't think is the case at this very moment. And we also want to look into the geometry engines. So right now we are using GEOS, which is planar, like expecting a Cartesian plane, and everything that should represent either part of the Earth is necessarily skewed by projection. So we hope to make use of spherical geometry using the Spherely library, which is exposing the Google's S2 spherical geometry engine. And it allows you to avoid projecting your data if you're trying to work with something which has data points in both Europe, Australia, and USA. For local data sets, it's going to be always much better to use GEOS for performance reasons. And the second geometry engine we would like to expose within GeoPandas once it's kind of mature enough is GeoArrow, which allows you to do two things, or allows us to do two things. In the first kind of shorter term step, it allows us to delay conversion from a GeoArrow representation in GeoParquet or GeoArrow in-memory representation to GEOS geometries. And optionally, it will allow us to replace Shapely with the geometry engine written in Rust on top of GeoArrow geometry representation, which should provide decent performance improvements as Rust folks are trying to sell right now. We also are developing Dusk GeoPandas, which allows us to properly scale GeoPandas into very large data. It's been a bit behind the development of the GeoPandas itself, so we hope to ensure that it will reach parity with GeoPandas in terms of the API. It will get full compatibility with the new Dusk expressions when creating the task graphs, because right now it's sort of broke the Dusk GeoPandas, and we hope to enable interactive mapping within Dusk GeoPandas because that's not supported right now because you assume that your data are not fitting in memory. by using data shader, which already supports does GeoPandas in some ways. Today it's me and Joris standing in front of you, but it's not just us who developed GeoPandas. It was started by Kelsey, but to this day we have 218 contributors who contributed code and hundreds of others who contributed to issues, to teaching materials, documentation, and anything else. So we would like to thank them all for the work and time they put into the project like GeoPandas. And we hope to release GeoPandas 1.0 release candidate in coming days, hopefully. We'll see how it goes. And you will be able to install it from both PyPI and CondaForge. Right now, if you install the pre-release of GeoPandas, you will get 1.0 alpha release, which doesn't include all the new things, but it includes all the deprecations and changes, so you can already test your code against GeoPandas to ensure that it won't break once the full 1.0 is released. And that's all from us. Thank you.
Thank you very much. Are there any questions? There's a question.
Yeah, thanks for presentation. Are you going to support any complex writing strategy, for example, for GeoParquet, like partitioning or creating this much more complicating stuff that you can do, for example, using directly pyogrio instead of GeoPandas?
Yeah, partitioned writing is not yet supported in GeoPandas. You can do it with DAS GeoPandas actually. So even if your dataset fits in memory, you could use DAS GeoPandas to do the partitioned writing. There is an issue open about it, so we certainly want to support it. And if you do partitioned writing, one of the improvements made over the last year in GeoPandas is that we support sorting based on a Hilbert curve, and that allows you to, if you then do partitioned writing, to also ensure that you have spatially, as much as possible, distinct partitions. But yeah, there are plans to integrate it in GeoPandas itself as well. But,
okay, the questions are always behind. 1 second. I bring the microphone.
Hi, thank you for all the work. Do you have anything new for fixing faulty geometries? You sometimes use buffer without any buffer zero, simplify without any arguments. Do you have anything new for fixing geometries?
yeah, I'm not sure which release. I think it's already a few releases ago, but for everyone using buffer zero, and that also included GeoPandas itself in certain cases, there is a better way, and that's called make valid. It's a functionality from GEOS that essentially is made for that purpose of trying to fix some invalid aspects of a geometry. And so you can, yeah, I will not say that it works for, like, will fix everything, but that's the more robust way to try to fix things. And that's a Shapely method that is also exposed in on GeoPandas level.